Today talk it's about continuing subject that we have, and we talk about the morphological image processing. Um, Initially, we will review some points on this morphological, and then we will have two, three quotes uh, about the performance of morphological image on an image. Then we will talk about two concepts of opening and closing and duality between these opening and closing. I think that we can reach up to this point, but if we can continue for the some other object subject today also, it's great. But the main plan is to finish this part, but I will try to cover more theoretical parts. And as I plan, next Monday we have more Matlab review about these points and some new theoretical parts. Then let us start today lecture and study this concept. Okay, no need to tell you again that we are from this part. This is our direction, and this is where we should now which location we are in the DIP subject. And this is the today agenda that we have for the review some points, some code in MATLAB, opening and closing, and duality between this opening and closing. Um, let's review again that morphological operation is a broad set of image processing operation that process the digital image based on their shape. In morphological operation, each image pixel is corresponding to the value of other pixel in its neighborhoods. Then by choosing the shape and size of neighborhood pixel, you can construct a morphological operation that is sensitive to a specific shape in the input's image. Morphological operation generally will be applied the structuring elements, which we call it STRL in MATLAB, to an input image and creating an output image of the same size. Let's review again that in morphological we had two famous, uh, sorry, four famous part. First was dilution, which add the pixel on the object boundaries. Erosion, which remove this pixel on the object boundaries. Open, which the opening operation erodes an image and then dilates the erode image using the same structuring elements of the both operation. And closing, which close operation dilates an image and then erodes the dilated image using the same structuring elements for both. For this open and close, I have more talks today, and mainly we will talk more about them. Something that you should know that the number of pixel added or removed from the object in an image depends on the shape and size of the structuring element used to process the image. Then in morphological dilation and erosion operation, the state of any given pixel in the output image is determined by applying the rule to the corresponding pixel and its neighbor in the input image. The rule used to process the pixel defines the morphological operation as a dilation or an erosion. Okay, let us start from first example that we will go to test on the MATLAB, and then we can see its performance. Let me share my MATLAB screen for you. Yes. Just give me the feedback that can you see this MATLAB
Yes, sir.
screen? Okay. The first program that we will going to test, it's about SE concept. Structure elements or SE was one of the concepts that we saw uh, last lecture and we discussed about it. Okay, as you will see, I'm going to read one image that is TX or text PNG, and then we will define the structuring elements of 2 by 2. Then we will erode the image with the help of IM function, and then I drop. Display the original image and display the dilated image. Let us see what will the what will be the output of this code. Okay, if I run this code, it's still busy, means that my MATLAB is engaged. Okay, what will happen? Here you will see that some words become dilated, or in the other words, it's not proper word, but it's little bit near to the bold function that we have in um, Word. What it had done, it's changed the neighbor of the each area of the word and make this text, little bit bolder. Okay, that was the first program that we test and see how to take the dilated text. Let us go for the next one and test the next code. But something that I say about this code is that the structuring elements is defined here by as a 3 by 3 array, and the basic syntax which requires the image and structuring image as an input to the function and dilated image is written as the output. But for the next one, we use the structuring elements of 6 by 1 and we will see the result. Let us uh, see the. Did you see the previous result on your screen or no?
No, sir.
Okay, okay, okay. I saw. Then why nobody tell me? I think I should share this desktop. Yes, yeah. That was the effects. Then I will once more will describe for you that here what is happening. It the word are become bold after testing. Is it visible now?
Yes, sir.
Yes, sir.
Oh, okay, good. Let's go for the next code that we have. And now we are using 6 by 1 array, SE array, and then use the erode image again. See, I change my matrix, my SE matrix on the image, and as you will see here, it's little bit corrupt, my image. See, the border are cropped. And the eroded image is shown here. What I mean that? I mean that if we expand the SE matrix, there is no guarantee that it will take your text better, or if we make it shorter, it's better. It just depends on the um, first is the aim and target of your coding inside the image. For this point, I should talk more on Monday. But just currently, I wanted that you become familiar with some uh, coding and initial coding in the MATLAB about this dilation. Okay, the next code that we will go to inbuild is that now I'm using the 4 by 4 square SE function. Actually, I use two SE functions. One is this 4 by 4. Another one is one line with the length of 5 and angle of 45. Then I will use the dilate image and erode image as the image 1 and subplot of image 2. Let us do one more thing. I think this I miss. We also show the original image. Then we can enjoy more about the this coding and see that what should be the difference. Let me do that also. Then it may be more enjoyable for us. That's C. Okay, this I will put 2. Oh, it can be 3 1. It can be 3 2. It can be 3 3 in the subplot. Now we can see the dilated one, eroded one, as well as the original image. Let me see that I don't have error. Then we can run it. Yes, yes, good. See here what will happen. Even what we can do, we can put some title here as the thing original. Let me see, am I right or it's bring the error for me? Let us test. Okay, this title was wrong. No problem. Easily I can search and no need to even uh, pressurize myself to remember what was the uh, title. See, please have this ability. Try to learn it. Whenever you forget anything or you maybe have some difficulty to remember, no need actually. MATLAB word is not something that all people should learn. All people should remember the what we can say. Remember the uh, all codes. See, there is lots of sample here that we can grab it, and even we can use. Yes, there is. See, then what I should learn is this. I think I was right, but why it didn't take that command? I don't know. Let me compare. Hmm? Oh, the word title was wrong. I got it. I got it. The word title was wrong. Yes. Then the first one is the original one that we will see here. I will add original image. Then the next one is dilated one. I can put this exactly this comment in the text, which will help me to compare this function better. See, nicely it's written there. And finally, what we will do is this is the eroded image at the end. But what is my SE, an effect of the SE? It's something that Our aim is that just review and see that how we should do how we should do this job. Okay, then it say that the second one it will not take. Oh, what? Why today? I don't know. I become like that. Okay, think that like you, I'm also sleepy now. Okay, wake up. This is the original one. See, now maybe this figure will give us the better concept regarding the image. See, the dilated one, original one, and eroded one. In dilated one, it's expand, but you will see that it's kill the text. In eroded one, it's shorted, okay, but again, it's destroyed the text. And if we want to say that this SE is useful or no, no, this SE is not much more effective for us to work on the image. We should think more what and how we can have the better SE matrix. That is something that next lecture I plan for you. Means on the Monday we'll focus more on the Matlab parts and also like, let me put this for you that you can uh, refer to that later on and you will enjoy it more. Okay. The third program that I bring that is again dilation and erosion in the image, but now uh, we are using one function that we got it sterile. Okay, in the sterile, which is the 4 by 4 square SE function, we are again going to show the dilated and eroded one and see the effect of this SE function. See. This is again dilated and this is again eroded. Just what I wanted to uh, teach you for this, for example, first was how to define the SE function. Second was how to show the erosion and dilation on the image and the effect of this SE on the image. Just like this, not more. More we will talk later on uh, the specific section that we have about working with this. The fourth, I think the number 4 program is again using this erosion and dilation and structuring elements with the MATLABs, but now we will change our application and go to uh, some other shapes, some circuit shapes which in that you can see the erode horizontal line, dilates one, and superimpose boundaries to see the effect of this morphological activity on the image. Yes, here you will see the original one, then you will see here at the this part uh, is the that was the original one. Second one is the threshold image and displayed one, and then eroded one, and then dilated one. These are the different. And last one is the superimposed boundaries. You know, this specific job, suppose, can show and will be higher on the QC control or quality control of the circuits, which we will do in the industry. It can be one good application for this even simple code. But now just I wanted to give some lights for what we can say for just to compare the result. The next is a code, which in that it's little bit different. We are going to compare the thresholding and dilation and put a little bit more high activity on this morphological shape. You will see here, yes, I'm going to change the neighbors and boundaries here. See, as much as I increase the boundaries like that, then the image become darker, means that I work on the neighbors and these neighbors will go up to end. Okay. Something like this, they call it particle removed program, or we can say that particle sizing, in the sense that we are going to, uh, in this program, with the help of two functions of BW label and IM field, the function of BW label will analyze the input's binary image so as to identify the connected components. For example, it can be any object in the image. It's return a so-called label image in which all pixel belongs to the first connected components are assigned a value 1, and all pixels belongs to the second connected components will assign the value 2. Then the function of iFill identifies the pixel consisting whole within the connected components and fill them. Okay. And just as you see, I work on the neighbors and then expand it, and you saw the um, effect. I use R image for this. I mean this one, and then as you will see, some of us are gone, but some others are still exist. It depends on the background and the crowded person which are there. Maybe one hint will be in this image that shows if you're finding for some specific object in the crowded background, maybe this morphological will work. Again, it's depend on the application and image uh, that we have. Okay, let us come back to our PPTs. That was very small activity and coding which we have done. For, but the main things that we wanted to teach, it's about the opening and closing activity in the morphological uh, or, image processing. Okay, what is opening? Opening is nothing but smooths the contours or eliminates the uh, prioritization. Um, it's and on the other sides we have one word that we call it closing, which is it smooths the section of the contours. Okay, and fuses the narrow breaks and long thin gulfs, eliminates small holes and fills gaps in contours. The operation means that the opening and closing are dual to each others, and these operations are can be applied few times, but has effect only once. Okay, remember that. Let us go deeply to see what is opening. Opening is some step like this. First, it will erode the A by B and then dilate result by B. Then if I want to show it, I can show it like this. This erode A by B and then dilated with the B. And in the other words, opening is the unification of all B objects entirely contained in A. Generally, this opening smooths the contours of an object and breaks uh, the narrow and eliminates thin parts. Then the closing is to smooth the section of the contours but it generates diffuses narrow breaks and long thin gulfs, eliminates small holes, and fills gaps in the contours. Uh, if we want to see this opening and closing in the uh, mathematical form, we'll see that the opening of set A by structuring elements B, we can denote it by A O B like this, as we saw. And then the closing set A by structuring elements B, we'll show it as A dot B. You will see that the um, equation is vice versa to the opening part. And the opening of set A by structuring elements B will denoted by these, which we can say that its unity of B, which is belong to uh, Z, and then the part of the B, which is Z, which belong to the uh, union of A. This is the mathematical form which we can show opening and closing. But with the example, if we want to see, suppose in the picture A, it will shows the structuring elements P, which is ruling along the inner boundaries of the A, and means that the dot indicates the origin of B. And B is a structuring element. C is the heavy lines, is the outer boundaries of the opening. Then at the end, what will happen? The complete opening or shaded one in the A will become clear. Or for the closing, suppose the structuring elements of B will ruling on the outer boundary instead of A, which that was in the opening was in the inner. Remember that? And the heavy lines in the outers is showing here, means that the outer parts for the closing will be checked, and the completes or shading is happening in the end part of this closing section. See more, the morphological opening, the structure elements is the small circle shown in various position. In the B, we shows the SE was not shaded here for clarity. And now you can see the effect of this opening and closing. Let us review like this, that opening is work just in the inner parts and closing will work on the outer side, or we can say shade of the shape. There is one concept regarding this opening and closing that we can say that these two are have the dual action, means that there is the duality between opening and closing, that you can see them opening and closing of dual of each other with respect to set of comprehension and reflection. And we can see the properties of them like this. A B is the subset or sub-image of the A. Oh, sorry. Yes. If C is the subset of D, then C O B or C is a subset of D O B O B. And if A O B and O B will be A O B. This is the for the opening. And for the closing, A is the subset or sub-image of the A dot B. And if C is the subset of D, then C dot P is the subset of D dot B. And C, A dot P dot B is equal to A dot B. You will see exactly the duality between these even mathematical equation that we have here. let's review again that opening is an identum operation. Once an image has been opened, subsequent opening with the same structuring element have no further effects on the image, and the closing of an image F by a structuring element S denoted by F dot S is the dilation followed by an erosion that we can see the formula here. Then the opening is also so called because it can open up a gap between object connected by the thin bridge of the pixel. Remember that? And it can open the gap between the uh, object connected and any region that have the survived the erosion are resorted to the original size by the dilation. You will see here the effect of binary image F with the 5 by 5 square and 9 by 9 square of SE. It seems that if the dimension will be less, then more data you can have in your image, but again it depends on the target of your programming part. And here you will see the binary image and closing with the 2 by 2 square structuring elements. In this case you will see that the dilation and erosion should be performed with some rotated 180 structuring elements, and typically the later is the symmetrical, so the rotated and initialized version of it do not differ. Suppose if you want to see, here I shows the closing with the 3 by 3 square structuring elements, and you will see that something happened here on this part and this area, and here also. Uh, some closing action happened on the image. Remember that closing is, they call it closing because it can fill holes in the region while keeping the initial region's size, like opening. Closing is also idempotent, and f.s is equal to f.s as we see, and it's dual operation of opening. Just opening is the dual operation of the closing. Then we can also have the equation between them. In the other words, we can say that closing or opening of binary image can be performed by taking the complements of that image, opening or closing with the structuring elements, and then taking the complements of the result. Then two complements and one opening or closing action we have in this process. Okay, then now let us have some demo on this opening and closing part. Suppose I have this image, as you will see, and then we are going to define the results based on the SE uh, with the SE matrix on that and see the result. Let me share my Matlab screen with you, and then we can see the performance and have small talk on this program also. Just 1 minute, please. I will share it, and then you will see the result. Yes, I think now you should see. Can you please see this screen?
Yes, sir.
Yes, sir.
Okay, what I have here, I have some open close shape. That is the name of my shape. First, I will read the image and convert it to the binary. Then after that, I define the SE and then open and close with the help of the IM open and IM close. Okay. IM open is I will store with BW1 and with BW2. I'm going to use the IM close one. Then display the result here. Okay. Then let us see up to here what I have done. My image. Yes. This is open and this one is closed. I don't know how much it's visible from your side. I wish that you can see. Then I use the sterile disk type to open and again open and close, means that change the SE part and then show it. Then I change the disk type reduce to 15 and then again show. See here? Yes. What this image means is something that we will go here. As you will see, the effects of opening and closing we have here. Let me make it. Yes. Yes. You will see the effect of opening and closing. The opening, I arrange them on the right side and closing on the left side. Sorry, vice versa. Left side is the opening part and closing are in the right side. You will see that the original image shown as the also center. What's happening on the opening? You will see that suppose in number 15 here at the end here. The line little bit removed here. There is one a small line. The right line is removed and also the edge little bit become circle shape. Okay. Um, Using the disk shape structuring elements with the radio of 3, 5, and 15 pixel, you will see that it's producing the image to the left for the opening and the image to the right were similarly produced by closing the image using the same structuring elements. The difference become more pronounced the larger the structuring elements employed closing on the test object and how this become more pronounced as structuring elements increase in the size. You will see that in the closing, maybe the data in the original image is not gone much more, and uh, we can see the result there. If we want to see our image also, is that our result also, which is much more better. From the closing, it's little bit has the sharpened uh, edge than the closing part. That let me zoom it. Maybe you will see better. Yes, see the edge here. You see the edge here and here. Okay, that is what I say. This is the this part is opening part, and this part is the closing on the shape that we have. Uh, Okay, then we have seen how the basic of morphological operation of dilation and erosion can be combined to define the opening and closing, and they can also be used together with simple logic operation to define the number of practical and useful morphological transform uh, um, transform transforms. This was the opening and closing. Let us go for the compound. Let's go for the compound operation, which in that we know that many morphological operations are represented as the combination of erosion and dilution. And Simple set theoretic operations such as complements of binary image like below equation can be used. Then we have one intersection which shows the F and G here with the two binary image, and we can have the union of F and G uh, binary image, which we can shows that h, x, and y will be 1 if x and y is 1, and then jx and y is 1, and h, x, and y can be 0 in the other case, and h1, h, x, and y is equal to 1 if x and y 1, or gx and y is 1, and the other case j is equal h, x, and y is 0. This is the setup operation on some binary image from left to right, a binary image of f, a binary image of g, and the complements of them and intersection of them, and finally the union. First one is complement of a of this image. Second one is the intersection between these two images, and last one is the union of these two images, which we shown uh, here to review. Two more points we have to review. One is that reflection, and another one is translation, that we can speak fast to finish this part. The reflection of a set B will denoted by the B uh, with the cap is defined as the formula that we have, and the translation of that set B by point Z, which Z has the Z1 and Z2 and will be denoted by BZ, we can show with this formula. What we can see from these two formula that I shown here, suppose we have the set A here, and then in the B is the reflection with the points A, and the C is the translation by the Z, means that we change this point. Or the other application can be like this, which here you will see that we have the noisy image of A here, then the structuring one, then the eroded image, and then opening one, and then closing one, which will help us to uh, take the information of the fingerprint as the example here. Okay, uh, that is okay for the first part of today's lecture. Okay, thank you. I will not talk much more for the second part of today's lecture. Um, just I will try to cover these hits and miss transformation. Uh, and after this 6 or 7 PPT page, Sajid will speak for us about his presentation. If um, we have time after his talk, we will come back and talk about the morphological application. Otherwise, we can start to work on morphological application from Monday onwards, and also that MATLAB coding part that I tell you later. Okay, in morphological process, we know that the basic morphological tools uh, is for shape detection. Let the origin of each shape be located at the center of gravity. If we think that exactly the center is the origin of the shape, if we want to find some location of shape, suppose x at larger image and say A, let x will be the enclosed by the small windows that we call it W, and the local background of x with respect to w is defined as a set of difference. Means that if I can remove the w from x, or I can remove the background from that, then the shape can come out. Okay. Then apply the erosion operator of A by X will get us the set of location of origin of X such that X is completely contained in A, and it may be also viewed geometrically as a set of all location of origin of X at which X find a match heat in A. This they call it heat. Uh, okay. Continuing, if we apply the erosion operation of complements of A by a local background set, uh, it should notice that the set of location for which X exactly fits inside the A, we can call it intersection of these two last operation above. The intersection is precisely the location sought. Formally, if we want to know, if we can be and denote it to the set of the composed of X, its background, we can have the B as the B and B1 and B2, which B1 is equal to X and B2 is equal to W minus X. Then the match or set of the match of the B in A can be denoted as A star B, like this. And then we can have the below or intersection of below equation. Let us see. Suppose here we have the image of A, we have the W, Y, X, and Z, and then this is the whole sets that we have. Okay. Then this is the set A that we have. A window of W. This is something that we can see in this shape, and then with the local background of X with respect to W, we have W minus X. Then in the C photo number C, this is the components of A we have, and in D we have the erosion of A by X. Then E is the erosion of A by W minus X, and finally the intersection of and showing the location of the origins X will be desired here. The reason for using these kind of structure elements that we call it B as the B1 and B2 is based on some assumption that two or more objects are distinct only if they are disjoint or discontinuous. In some application, we may interested in detecting the setter pattern, suppose combination of T, S, and zeros, and not for detecting the individual object. In this case, a background is not required, uh, and the hit or mistransform reduce to the simple erosion. The simplified pattern detection scheme is used in some of the algorithm for identify the characters with the text. Then these hits and miss will use mainly or with lots of application like extracting the text. And you know that if you can extract the text, then maybe you can extract the handwriting, you can extract some maybe signature or some shape, but maybe they will use for text. Okay, remember this point. Let us review again. If we B denotes the set of composed D and its background, the match or set of the match. B in A, we can show it A star B like that. And then we have the B, we have the object and the background inside of the B, which we can show it in this formula of B1 and B2. Then you will see the here you will see the windows that we have. Again, same process. With the C, you will see the complements of A, and then this is the erosion of A by D, and finally, this is the intersection that you can see and will help you to find the location of X and Y. Then, in hits or miss transform, first we want to assume the center of the object, and then we will try to remove the background of the shape. Okay, I little bit worried that if I start the second part of morphological algorithm application, then Sajid will not have the proper time to finish his project. But anyway, uh, just I should give you some description that we have the basic morphological algorithm around 9 that we will go to compare and also do the little bit coding for them in the MATLAB section part. And mainly we will talk on the next week about this subject, and we will see the performance of this. For again today, DIP, you don't have a task till the time that I will give you the task. I think next week then you have lots of tasks for DIP. I think it's okay, just temporary. I will stop uh, to see the time and also give you actually the time to Sajid. If we have time after he's talking, then we will come back and discuss. Otherwise, till this application and morphological, uh, we can continue on the next lecture. Then the basic morphological algorithm, or on the otherwise application, can be divided by to 8. These are some parts that we will talk regarding them, and maybe up to number 4 or 5 today we can cover. Mainly, I will try to cover up to number 4 because half 4 will be remain for next, and then we can do the MATLAB job on that. First is boundary extraction, which is in this algorithm, you erode the A by B, and then you will make the set of difference between A and the erosion. Something that you should know is that the thickness of the counter depends on the size of the constructing object minus B. Think like this, that you have the set A and you have set B, and you know the center of B. Now A and B erosion will be like this, and then uh, complement of that, or whatever, removing the difference between the main image and this one can be uh, this part, or beta A, as we can see the A minus erosion of A and eroded of the A and B. Where it can be used, it can be suppose used with this boundary extraction job, which in 3 steps. First is erosion, and second part is the minus of that. You can have the nice target detection here. And this boundary extraction of a set of A can be obtained by first eroding A by B and then performing the difference, as we said before. And once more, you can see the example, same example that we have, that was repeated. And this is the act that we have done on one image. See the simple binary image we have with the first representation in white. And second is the using of the equation that we have with the structuring elements. You will see that how it can detect that person. The second application or second algorithm is hole filling, which in that may define as the background region surrounded by the connected border of the foreground pixel. Uh, it can be like this, that first we will denote a set of whose elements are 8 connected boundaries, and each boundary enclosing a background region, for example, a hole. And given a point in each hole, the objective is to fill all holes with ones. Uh, then forming an array of x0 to zeros, the same size as the array containing A, except the location in x0 corresponding to the given point in each hole, which we set to 1. Then we can have the equation that we have, and we will continue this iteration till the time that xk is equal to x minus 1. Let us see it. First, we have the whole filling application. A is the shown shaded part or of set A. The B is the complement of that. C, number C, as you will see, is the here. This is the structuring elements of B. Then this one, it's the initial point inside the boundary. Then the rest of them, as you can see here, rest of the image. Let me, yes. Rest of the image are various steps, and the final result is something like this. You will see that here, how this structuring will come and sweep the image. The maybe whole filling you can see also here, which we can see the binary image here, white dot inside of the one region is a starting point for the whole filling. This is the center of the image that already we thought we should find. And B is the result of filling exactly that region here. And C is the resulting the filling of all hole in the image. The third one is the extraction of connected components, which in this algorithm, we have the central too many automated image analysis application. In this algorithm, let A be the setup containing one or more connected components and form an array of x0 of the same size as the array containing A, whose elements are zeros except at each location known to corresponding to a point in each connected components in A, which is set to 1. Then extraction of connected components, something like central to the many automated image analysis application, can be shown with this equation that we have. And then let us see the performance of extracting connected components. The number A is the extraction elements. B is the array of connecting of the sets with the one connected components. And number C is the initial array containing a one in the region of the connected components. Then D to G is the various steps that we had to do the job. Number A is this much, please remember. This is B, this is C, D, E, F, and G, which is the G is the final result of this algorithm. One more image that we can see from the X-ray of the chicken fillets with the bone fragments. Then this is the threshold image, and number C is the eroded with the 5 by 5 structure. And a number of pixels in connected components of C are showing here. Suppose connected components, a number of pixels relation are shown on this uh, um image. The next algorithm is convex hull, which is a set of suppose A, we call it convex if the straight line segments joining any 2 points in the A lies entirely within A, then the convex hull edge of an arbitrary set of S is the smallest content set of S. Let us see the formula. In that, we have the BI, which is I is equal to 1, 2, 3, and represent the 4 structuring elements. Then the procedure consists of implementing the equation like this. And when the procedure is conversed, we can have the other convex hull equation. which I don't want you to memorize it, but I want just you to know the act of them on the image. Uh, for this convex hull, just hold on. Yes. We can have this example, which in had we have the structuring elements here, B1, B2, B3, and B4. And then you will see that we have the sets of A, and then the result of converts with the structuring elements, which is showing, and then will give us the convex hull showing contribution of each structuring elements here. This is the result of limiting growth of the convex hull algorithm to the maximum dimension of the original sets of the points along the vertical and horizontal uh, direction.